The energy industry is facing one of the biggest challenges in its history. How can a greener future be achieved? The answer seems to lie with low and zero carbon generation technologies, along with the electrification of some of the main contributors to greenhouse gas emissions. However, the UK energy grid is already outdated and strained, so adding large amounts of electric heating or electric vehicles could cause disruptions to customers and cause the grid to become overrun. If we want to become greener, the grid will need to change. One solution is the smart grid. Smart grids allow for two-way communications of energy and information between the consumer and supplier. The communication network and control systems involved in a smart grid would allow for large-scale uptakes of electric vehicles and heating, as well as an increase in renewable energy resources. This would allow the grid to be more reliable, flexible and efficient. This project looks to create a smart grid controller that manages the supply and demand of a network by implementing smart grid technologies. The controller is a combination of a software interface that determines what techniques to use and by how much, and a hardware model grid.
Our controller analyses the hourly balance between supply and demand over a 24-hour period. If there is an imbalance, the controller must accurately select which technique to implement, as well as the quantity to implement it by, in order to reach an equilibrium. There are three smart grid techniques it can use: renewable control, electric vehicle scheduling, and demand-side response, which can alter the supply and demand in the system. This decision will be based on the market price and the availability of the techniques. After implementing these, the network should be balanced and the controller will continue to iterate until the 24-hour period is finished.
This isn't an ideal world. The controller can't just make changes as and when it pleases. It is constrained by distribution network restrictions, and that's where IPSA is used. IPSA software has been used to set up a realistic network in St Andrews. This allows us to run load flows every time the controller wants to make a change to check that this is in line with the network restrictions. If there is no restrictions exceeded, the controller can make these changes. If there is a restriction, the controller will have to make a different change or use another technique to make them balance. This makes sure that all the changes are realistic.
We decided to create a model grid to easily show what our controller can do. Our design has a replica of the St Andrews network on it and allows users to alter supply and demand using buttons connected to an Arduino circuit. The controller will run the simulations based on the changes the user makes and will show the results of this using LEDs. So we have two LEDs per technique, a green one which shows when the technique has been successfully used and a red one to show when it's been unsuccessful. We also have a green LED that will light when supply and demand are equal, and the red LED to show when there has been a network limit exceedance. This allows the user to interact with the controller and fully understand the steps that it is taking.
Our smart grid controller is complex and capable of handling a variety of scenarios. It achieves the initial design aims of being customer focused, easy to use and realistic. The final product would be well suited for use by DNOs, as this multi-technique and optimally controlled smart grid controller could help lay the foundations of a smart grid that increases the uptake of low carbon technologies.